Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're again talking about independent events, but I'm going to introduce you to a new idea called simplified probability trees. So here is a question we have previously answered using probability trees. So pause the video and double check you could draw the probability tree for this scenario. Okay, it was a fairly in-depth probability tree, but hopefully you got something as follows. Now, subsequent to that, you can be asked questions, and the questions may be something like the following. What's the probability of getting a green twice? Well, you can look up here and you can see the probability of getting a green and a green is 16 out of 81. What's the probability of getting not green twice? Well, let's look at all those scenarios. There's a green in each of these. There's a green here. You can either have yellow, yellow and yellow, red. They're both not green twice. Or you could have red, yellow and red, red. So you add up each of these. 9 add 6 is 15. Add another 6 is 21. Add another 4 is 25. It would be out of 81. Okay. Now it turns out that that was probably a little bit of a complicated probability tree, far more so than you needed, because in this scenario all you really care about is whether something is green for the question or it's not green. Okay, so the probability tree didn't really need three arms of green, yellow, red. You could have had two arms, green and not green. So sometimes there's an opportunity to draw a simplified probability tree, and that's what this video is about. So let's redo this particular question with a new probability tree. If you feel like you can do it, pause the video and go ahead. Otherwise, I'll go through now. So what's special about this question is you're only interested in when something is green, okay, or when it is not green. So that means you have the opportunity to draw a simplified diagram, and it would look something like this. Your selection on the first choice could either be green or not green, and on the second choice it could be green or not green. So your probability tree is far simpler, and if you take the opportunity to draw a simpler one like this, it makes life so much easier in the long run. That last probability tree was rather messy and large, and this one's going to be far easier. So the probability of green is 4 out of 9, so you complete that everywhere you have green. And the probability of not green, well, it's 3 add 2, which is 5 out of 9, so you can complete those there. So the probability of getting green twice, the probability of green and green, well, that's 4 ninths multiplied by 4 ninths, which is 16 out of 81 as it was before. But the probability of not green twice is 5 ninths times 5 ninths, so not green and not green. 5 ninths multiplied by 5 ninths is 25 out of 81. And if we look back, that's exactly what we got in the previous scenario with so much less work. And it's just an opportunity for you to look out for these potential opportunities to draw the simplified probability trees. Alright, we've got some more questions. Pause the video and have a go at each, starting with this one, the first one. Okay, here we've got a scenario of taking marbles out of a bag. Again, we see that Decca picks one out of the bag, notes its colour and replaces it, and then she takes another marble from the bag. What's the probability of getting exactly one blue? Now, because that's the only question we're asked and it's only about whether it's blue or not, we can draw a simplified probability tree. It would look something like this. On the first pick it's either blue or not blue, and similarly on the second pick it's either blue or not blue. So a nice simple diagram like this will help us simplify this problem. So it's either blue with probability 3 out of 11, which we can put in all the places for blue, or it could be not blue, which I'm just going to write not blue like this, which is obviously 7 add 1 is 8 out of 11, so not blue in these scenarios here. So there you go, there is our simplified probability tree, making life a whole lot easier. So it says to us, what's the probability of getting exactly one blue? So exactly one blue, you must get a blue and not blue. So it's either probability of a blue and not blue, or it's getting not blue and then a blue. So the probability of not blue and a blue. So this would be 3/11 multiplied by 8/11. So 3/11 multiplied by 8/11, which is equal to 24 out of 121, or it's going to be 8/11 multiplied by 3/11 the other way around, which again is 24 out of 121. Therefore, the probability we're looking for, the probability of 1 blue, is the sum of these two things. 24 add 24 is 48 out of 121, and we're done. And that's way easier than if we considered the case 3 red and yellow. We would have had so many branches. Here it was nice and easy for us. Okay, let's try another question. Pause the video, have a go. So a standard fair dice is rolled twice. What is the probability of getting an even number on the first roll and any number except 5 on the other? So rather than maybe using probability trees here with getting 1, 2, 3, 4, 5, 6 on the first and 1, 2, 3, 4, 5, 6 on the second, that would be a very complicated probability tree. We simply care on the first throw of getting an even number or not, and on the second throw we care about getting a 5 or anything that's not a 5. So our simplified tree can either on the first roll can be a head or not, so it would be an even or not, so it would be an even or an odd, and on the second we're interested in if you get a 5 or if you don't get a 5. Simple as that. So 5, not 5. And that's a very simplified probability tree for us. The probability of even is a half, the probability of odd is a half, because there are 1, 2, 3 odd numbers out of 6 and there are 3 even numbers out of 6. The probability of a 5, there's only one 5, so it's 1/6. So the probability of not 5 must be 5/6. And similarly here. Now it said to us in the question, what is the probability of getting an even number on the first roll and any number except 5? So we want an even number and anything that's not 5. So it would be this scenario here. So the probability of an even and not 5 would be a half multiplied by 5/6. And half multiplied by 5/6 would be 5/12. And we're done. Nice and easily like that. And that's it for this particular video. Thanks for watching.